Hi, everybody. I hope you can hear me. My name is Josef Vaculík, and I've prepared an Indeed session focused on the basic principles behind Bitcoin and other digital currencies. We'll start with a brief overview of Bitcoin and its history. Then we'll be taking a look at the Bitcoin ecosystem and its history. We'll be explaining some basic terms like keys, addresses, wallets, and briefly talk about the network architecture and the data structure that holds all the Bitcoin data, that's blockchain. And last but not least, we will mention a few words about Bitcoin economics and the most pressing Bitcoin issues. After this Indeed session, you should have basic understanding of the way Bitcoin works under the hood. And if at any time you have any question or you have a feeling I'm talking nonsense, don't hesitate to interrupt. Okay, let's start with the very basic question. What is Bitcoin? Here you can see a few opinions from the commentators on the novinky.cz, which is one of the most visited news website on Czech internet. So as you can see, some people think that Bitcoin is the biggest scam in the history of finance, invented by a global electric power corporation, and so on. But let's get serious. So what is Bitcoin? Well, there is about 100 correct answers to this question. So I picked 3. Bitcoin definitely is the very first widely accepted digital currency that was created by Satoshi Nakamoto. It is also a collection of concepts and technologies that form a digital money ecosystem. And it also is a distributed peer-to-peer system with no central server or point of control. The units of currency, abbreviated by BTC, are entirely virtual, implied in transactions that transfer value from sender to recipient. The possession of Bitcoin is proved by the possession of private key. The private key is used to sign the transactions on the Bitcoin network to unlock the value and spend it. New Bitcoins are created through the process called mining, which basically is competing to find a solution to a mathematical problem while processing Bitcoin transactions. New Bitcoins are created every 10 minutes on average. Later we will talk in more detail about why it is on average. And the rate of Bitcoin issuance halves every 4 years, ending in about 2140 with almost 21 million Bitcoin. And the smallest denomination is 1 Satoshi, and 1 Bitcoin equals to 100 million Satoshis. By design, Bitcoin is deflationary currency as opposed to the so-called fiat currencies like dollars, euros, etc. Okay, let's dive into the history of Bitcoin. The first time the term Bitcoin appeared in public was in August 2008 when the domain bitcoin.org was registered. In November of the same year, a paper by Satoshi Nakamoto titled Bitcoin, a peer-to-peer electronic cash system, was released in a cryptography magazine. And Nakamoto implemented the Bitcoin software as open source that you can find on GitHub. mostly written in C++, and released the code in January 2009. And on the 3rd of January of the same year, Nakamoto mined the first block of the chain, known as the Genesis block. And embedded in the coin base of this block is the following text. If you are wondering what that means, it's the title of the British newspaper, The Times, from the 3rd of January 2009. And that article describes that the Minister of Finance of Great Britain is seriously thinking about using taxpayers' money to save banks. And one more important date from the history of Bitcoin is so-called Bitcoin Pizza Day, which dates back to the 22nd of May 2010. And on that day, the first purchase for Bitcoins was made when a Hungarian programmer who helped Satoshi Nakamoto with Bitcoin development offered in a chat room 10,000 Bitcoins to anyone who would order 2 large pizzas and let them deliver to his home. So now we can think of these pizzas as the most expensive food probably ever. Okay, now we'll take a look at the Bitcoin network. As you can see in this diagram that I've stolen from the book Mastering Bitcoin, the Bitcoin network consists of users who control their wallets containing private keys. They use the private keys to sign transactions that transfer value from one node to another. These can be exchanges, merchants. And then there are miners who verify the transactions and put them into blocks and add the blocks into the blockchain, which is the ledger of all the Bitcoin transactions. Now I will try to explain the basic terms necessary to understand how Bitcoin works. We'll start with keys and addresses. So, as already mentioned, Bitcoin ownership is established through digital keys, Bitcoin addresses, and digital signatures. Digital keys are not stored in the network, but are created and stored by users in a file or simple database called wallet. Bitcoin transactions require a valid digital signature to be included in a new block. And the digital signature can only be generated with a secret key, meaning that anyone with a copy of the secret key has full control of the Bitcoin. And keys come in pairs of private and public key. And now I would like to describe the process of the creation of the keys and addresses. Everything starts with a private key, which basically is a 256-bit random number that can look like this. Sorry. And this number is used as an input for a one-way elliptic curve multiplication function. And the result of that function is public key, which then is used as input for a one-way hashing function. And the result of that function is Bitcoin address. Both of these functions have one thing in common, and that is they are both one-way, meaning that it is pretty easy to compute the result from left to right, but it is computationally infeasible to do the same the other way around. So it is almost impossible to get the private key from the public key. Now, let's talk about Bitcoin address. Bitcoin address is a string of characters and digits, usually beginning with the digit 1, sometimes with digit 3, that can be shared with anyone. It can look like this. And it is computed using two different hash functions on the public key. So public key is an input, then the SHA-256 function is applied, and on the result, the write MD160 is applied, and the result is a number that has 160 bits, and the number is encoded using base 58 check encoding, which is very similar to the well-known base 64. But some of the characters are omitted because they can be easily mistaken for each other, like 0, uppercase O, lowercase l, uppercase I, and also the plus sign and slash sign are omitted from the base 58 encoding. When talking about addresses, interesting fact that not many people know is that there exists something called vanity address. Basically, vanity address is an address containing a human readable message, which can look like this. So if in the future our company decides to accept Bitcoin, we can have an address like this. The first character is not optional, so there usually is number 1, but the rest can be optional, so it can look like this, 1 CN group and then the rest of the address. If you are wondering how such an address is created, there is no simple way to create it, so it can only be done by generating and testing billions of private keys. The bad news is that if you would like to do this generation on your own, it would take you for such an address about 2 to 3 months. But the good news is that the generating can be outsourced to a pool of so-called vanity miners, like that vanity pool appspot.com. And in that case, it would take about half an hour and cost you about $5 to $10. Okay, now let's talk about wallets, meaning Bitcoin wallets. These are basically keychains or containers storing and managing users' keys, plus usually there is an UI. The implementation of wallets is usually done as a structured file or a simple database. What's most important to realize about Bitcoin wallets is that they do not contain any Bitcoin. All they hold is the keys. Usually they hold both the private and public key, but it is enough to hold the private key only because the public key can be generated. The Bitcoins are stored in the blockchain, and users control the coins by signing transactions with the keys from their wallets. There are two basic types of Bitcoin wallets. The old ones are non-deterministic, meaning that when there's multiple keys, the keys are not related to each other. But nowadays, we usually use deterministic wallets where all keys are derived from a single master key called seed, where seed is a randomly generated number that's combined with some other data. And why the deterministic wallets are used is that the seed is enough to recover all the derived keys and what it import and export. Most advanced form of deterministic wallets are HD wallets, which is short for hierarchical deterministic, where the keys have a 2 to 3 order. So the keys are not related to each other. They are not deterministic, but they are hierarchical. They are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are not deterministic, but they are hierarchical. So the keys are can be derived in a tree structure, like you can see seed, from which there's a master key generated, and then in a tree-like structure we generate further keys. So in case it can have its own key, but all the keys, you have a corporation, are generated from the seed, so it is enough to recover all the keys if you have the seed. The most advanced Bitcoin wallets are hardware wallets, which are special types of wallets that store the user's private keys in a secure hardware device. The one in the picture is Ledger, and the other one from the most well-known is Trezor, which some of you can see here. It looks like this. So these hardware wallets have private keys that are generated by the device and never leave it. Thus, they cannot be accessed by malware. Recovery seed is generated when the device is initialized. There's also PIN preventing keyloggers from recording it, even when entered on a compromised computer. Also, there can be encryption passphrase set on top of the PIN protection, and more passphrases can be used for plausible deniability, meaning you can have multiple passwords, and even if you mistype the password, it will not throw an error, but it will create an empty wallet. Here I have included a link to a YouTube video describing the features of the Trezor wallet, but I'm afraid we don't have enough time here to watch it, but I will definitely copy the link to the Slack in the channel so that you can take a look if you are interested. And in the meantime, we'll move to Bitcoin transactions. Transaction tells the network that the owner of some Bitcoins has authorized the transfer of some of those Bitcoins to another owner. Each transaction, with the exception of one, but that's not important, has one or more inputs and one or more outputs. When you sum up the inputs and some of the outputs, you might notice that there's a difference. The sum of the inputs is slightly greater than the sum of the outputs. And the reason is that the difference is a transaction fee, which is an incentive for the miner to put this transaction into the block. The transactions create chains, meaning that an output from one transaction can be used, and usually is used, as an input for another transaction. Like you can see here, where we have 3 transactions. The first one from Joe to Alice, and then the output from the first transaction is used as input for the second transaction, where Alice is sending part of the Bitcoins from the first transaction to Bob, and the rest is sent back to Alice as a change. And also there's obviously a transaction fee. And then we go on. The output from the second transaction is used as the input for the third transaction. And this way, all the transactions in the Bitcoin world are chained. When talking about transactions, there's one more important term, and that is transaction pool or memory pool, which is a temporary list of unconfirmed transactions that most of the Bitcoin network nodes maintain. When a transaction is received and verified, it is added to the transaction pool, and then it is transmitted to the neighboring nodes. Now let's describe how the addition of the transaction to blockchain works. Wallet application sends the transaction to all the nodes it is connected to. Any node that receives new valid transaction will forward it to other nodes. And transaction propagates through the network this way, reaching most of the nodes within a few seconds. But the transaction does not become part of the blockchain until it is verified and included in a block by mining. Miners aggregate to block and compete behind the block. And when a block is mined, the transactions in that block become part of the blockchain. We'll talk more about how mining works later. Well, now. Okay, here you can see how some people think the Bitcoin mining works. I can tell you it is not the correct opinion. Okay, and how does it work in reality? Well, first, let's answer the question, why mining? Well, mining is there because of two main purposes. The first one is temporary for at least another 120 years, and that is creating a new Bitcoin. And the other one is, or should be there forever, and it is there for creating trust. As already said, mining is basically a race to find a solution to a block of transactions. The solution is called proof of work. And it is repeatedly hashing the header of the block with a random number using a cryptographic algorithm until a solution matching a predetermined pattern is found. First miner to find such a solution wins the round of competition and publishes the block into the blockchain, and then the race starts again for a new block. The proof of work algorithm is a hash algorithm that takes an arbitrary length data and produces a fixed length deterministic result. The important feature is that it is computationally infeasible to find two different inputs that produce the same output. To find a solution to the proof of work algorithm, there is a number called nonce that is used as a variable added to the input. After the nonce is added to the input, this data is hashed, and if the resulting hash is less than the current target, the solution is found and the block is mined, and the miner gets the reward in the form of the new Bitcoins. And if the resulting hash is greater than the target, the nonce is incremented and new hash is computed. Now let's talk about the feature that enables the Bitcoin network to create new Bitcoins and mine the blocks on average in 10 minutes. And that feature is retargeting to adjust difficulty. And it works based on the proof of work target, which is a dynamic parameter that is periodically adjusted by all the nodes in the Bitcoin network to meet 10-minute block interval goal. The retargeting occurs automatically and independently on every node, every 2016 blocks. And it works like this. Each node measures how long it took to find last 2016 blocks and compares it to the expected time of 20,160 minutes. And if the network is finding blocks faster, the target difficulty increases, and if the network is finding blocks slower, the target difficulty decreases. In the old days, it made sense to mine Bitcoin on your own, on your personal machine, where you had a significant chance to mine new Bitcoins. But if you did this today, it would take you years on average to mine a single block. And for that reason, miners collaborate to form mining pools where they pool their hashing power and share the reward. By participating in a pool, miners get a smaller share of reward, but might get rewarded every day. The successful miners pay the reward to a pool Bitcoin address, and the pool server then periodically make payments to miners' addresses and keeps a small percentage as a fee for the pool. Rewards are split to miners based on the number of shares they earned, and to earn a share, a miner needs to find a solution that is lower than the pool target, and the pool target has lower difficulty than the overall mining target. So it is much easier to find a share, to earn a share, than to mine the block. Now, let's briefly talk about the Bitcoin network architecture. As already said, Bitcoin network is a peer-to-peer network on top of the internet with flat topology. There's no server, no centralized service, no hierarchy, no one for the Congress to blame. Decentralization of control is a core design principle. And the nodes in the network are equal, but can take on different roles. In all nodes, there's a routing node included, but there are also specialized nodes like wallets, miners, or full blockchain nodes, which currently has over 200 gigabytes in size. Now, let's describe what happens when a new node attaches to the Bitcoin network. Well, when a new node boots up, it must discover other nodes on the network. Therefore, the client software contains reference to seed nodes, which are long-running stable nodes. And one of these seed nodes is used as a DNS seed. And after the seed node introduces the new node to some peer nodes, new node is disconnected from the seed node. And to connect to a new node, there's a TCP connection established, usually using port 8333. And now we are getting to probably the most overhyped word from the Bitcoin space, which is blockchain. So what is blockchain? Blockchain is basically an ordered backlinked list of blocks of transactions that's usually stored in a simple database. The Bitcoin Core client, which is the reference implementation of Bitcoin that you can find on GitHub, stores the blockchain data using Google's LevelDB. Blocks in the blockchain are linked back, each referring to the previous block in the chain, and each block is identified by a hash using the SHA-256 hash algorithm on the block header. And each block also contains the previous block hash field in the block header. So this way, the block hashes cannot be tampered with. And sequence of hashes creates a chain going back all the way to the first block ever created, the Genesis block. And in this diagram, I'd like to describe how the creation of new block works. Well, let's assume for simplicity that we have 4 transactions, A, B, C, D. So the first thing the miner's software does is that it hashes all the transactions separately. Then it hashes the pairs of transactions. And as a result, there is a combined hash of all the transactions. And if anyone would change a single bit in any of these transactions, the resulting hash would be different. Also, what's included in the block or block header is the hash of the previous block. We are now creating block 50, so there's hash of block 49. Also, timestamp is added and the nonce. And all these information are contained in the block header, which when hashed using the SHA-256 algorithm results in a value that's lower than the current mining target. So if you are asking what's there in the block, it obviously are the transactions, but aside of these, there's 4 bytes for block size, 80 bytes contains block header, and then there's 1 to 9 bytes for transaction counter, describing how many transactions the block contains. The maximum block size of Bitcoin is 1 megabyte, and the average size of the block in 2018 was about 0.8 megabytes. And current block height, meaning how many blocks have been created, is about 585,000. Now, before we run out of time, I would like to mention at least the most pressing Bitcoin issue today, and that is scaling. The issue has to do with the maximum block size of 1 megabyte, because as a result of this, the current median transaction speed of Bitcoin network is about 5 transactions per second. And even if the transactions would be small as possible, the maximal throughput would be 27 transactions per second, which is not very much, at least compared to things like Visa and MasterCard, which can do thousands of transactions per second. And to tackle this issue, there have been a couple of solutions proposed. Some of these solutions require hard fork, which basically is an upgrade in the software that is not backwards compatible. So one of these solutions was let's let's just increase the block size. And this is how Bitcoin Cash was created, because Bitcoin Cash has the maximum block size of 8 megabytes. And as a result of this, it is much cheaper to send transactions, to make transactions using Bitcoin Cash. Another solution to Bitcoin scaling that would require hard fork was to decrease block intervals. So instead of 10 minutes to use, for example, 1 minute. But this has a drawback that it can make the network unstable. So, but there are other digital currencies that use shorter block times. But the solution that seems to have most support is a layer 2 solution, meaning a solution that exists on top of the Bitcoin network that allow us to make payments that are not immediately put on the public blockchain. As a base for these solutions was SegWit was used. SegWit is a short for segregated witness. And this is a feature that makes transactions smaller by removing signature from the transaction. The advantage is that it doesn't require a hard fork, only soft fork, which is a software upgrade that is backwards compatible. And this solution was introduced in 2017, and it's been activated, and now there are thousands of Bitcoin nodes that support SegWit. And on top of SegWit, there's another solution to Bitcoin scaling issue, and that is Lightning Network. Lightning Network uses micropayment channels to scale its blockchain's capability to conduct transactions. It enables unlimited number of transactions without committing them to the public blockchain, meaning it supports basically streaming of money. I would like to describe it on this example. The green rectangle is the Bitcoin main blockchain. And then let's assume we have two parties, like there's a company, this yellow circle, and there's a consultant that works for a company. And the deal is that the consultant gets paid, let's say 0.01 Bitcoin for each minute of his consultancy. So at the beginning, they both commit some Bitcoin value. It can be also zero, but in this example, let's assume both sides commit half a Bitcoin to the Bitcoin network, and then they create the payment channel. The consultant does his consultancy, and for each minute he's paid 0.01 Bitcoin. So after 30 minutes, when his work is done, on his side, on the side of the blue one, there would be 0.8 Bitcoin, and on the side of the yellow, there would be 0.2 Bitcoins, and these would be then committed to the main blockchain by signing the smart contract, which is a piece of code that describes the deal. And when both sides sign that contract, the transaction is propagated through the network, and after successful validation, the consultant gets his payment in a single transaction, although the money were streamed in 30 separate payments. Okay, aside from the main Bitcoin blockchain called mainnet, there are also other blockchains for testing, like testnet, segnet, or rectest. And the last thing I want to mention is a few words about Bitcoin economics. I've already mentioned most of these. New Bitcoins are creating during the block creation at a fixed and diminishing rate. Average block creation time is 10 minutes. Every circa 4 years, exactly is 210 blocks. The issuance rate is decreased by 50%. Everything started in 2009 by Satoshi Nakamoto with 50 bitcoins per block. Current rate is 12.5 bitcoin, but this will halve in about 1 year to 6.25. And in approximately 2140, there will be the last Satoshi issued, and the final number of Bitcoin supply will be the number that you can see here. So almost 21 million Bitcoin. But the thing is that there's one person who managed to mine 22 million Bitcoin, and that is Chuck Norris. And with that, I would like to thank you for your attention. And if you have any question, fire away or email me, Skype me, whatever.
Yeah. Thank you. It was great.
Thank you.